Welcome to this video. Here we learn how rotating magnetic field is produced in three-phase induction motor. Initially, it looks very complex. I will try to make it easy for you. So in this figure, we can see this one is a three-phase induction motor. This is three-phase induction motor. And this one is the stator winding of three-phase induction motor. So in three-phase induction motor, we supply a three-phase AC supply, that is here three-phase AC connection is there. So this is R phase, then Y phase, then B phase. So RYB three-phase AC supply. The three current flowing through the stator windings. So in the stator winding, three-phase current flowing in the stator winding, that is the R phase current, Y phase current and B phase current. So we are giving three-phase supply in the stator winding. The three current have the same magnitudes but separated by 120 degree in phase. So in this figure you can see this is the R phase, then this is Y phase, this is B phase. So that is the current flowing through the R phase. IR is equal to Im sine omega t. Now this is Y phase is lagging by 120 degree. And this is here the IR is the reference. So here it is how much? 120, 122, 40 degree. So what I can write, Iy is equal to Im sine omega t minus 120 degree. Ib is equal to Im sine omega t minus 240 degree. If I go in these directions, but from here it is plus 120 degree. So I can write same thing, Ib is equal to Im sine omega t plus 120 degree. So these are the three currents create magnetic fields in stator windings. So stator with these three winding placed 120 degree apart. So each winding produce a magnetic field when current flows through it. So when balanced three-phase voltage is supplied, to a balanced three-phase winding in the stator of an induction motor, the resultant flux remains constant in magnitude but rotates in synchronous speed. That is, the speed of rotating magnetic field is synchronous speed, which related to the supply frequency and number of poles for which the winding has been designed. So actually we designed the stator winding based of our requirement, where the speed is 1500 or 3000 RPM. So this is termed as rotating magnetic field formed in the air gap of the motor. That is in between the stator and rotor there is some air gap, and in this air gap rotating magnetic field is produced. So consider three identical coils located on axis physically at 120 degrees. That is, this is R coil, and 120 degree apart there is Y coil, and another 120 degree. I will draw the B coil. So three identical coil located on axis physically at 120 degrees in space. That means these coils are physically they are apart from each other by 120 degree. So each coil is supplied from one phase, one phase of balanced three-phase supply. So each coil will produce alternating flux along its axis. So let the instantaneous fluxes are given by phi 1 is equal to phi m sine omega t. So phi 2, so this is phi 1. Now that is the flux. So we will draw this one as, this is phi 1 phi 2 and this is phi 3. So these are the alternating flux. Phi 2 is equal to phi m sine omega t minus 120 degree. Minus 120 degree. Now phi 3, what I can write? Phi 3 is sine omega t minus 240 degree, or here it is 120 degree. So phi 3 is equal to phi m sine omega t plus 120 degree. So these are the three alternating flux. Now at any instant the vector sum of these three magnetic field produce at any instant the vector sum of these three magnetic field produces a resultant magnetic field, resultant magnetic flux. So resultant magnetic flux has constant magnitude. So we will show it. So resultant flux produced by this system may be determined by resolving the component with respect to the physical axis. So I will draw this figure 2 again. This is figure 1. This is figure 2. So this is phi 1. This is phi 2. So in between this is 120 degree. And we have to draw phi 3. So this is also 120 degree. 120 degree. What we want? Resultant flux of the system may be determined by resolving the component with respect to physical axis. So we know that there are two components. One is horizontal component, another one is a vertical component. So we will draw the horizontal component. Phi h is equal to phi 1 minus phi 2. How much? The difference is 120 degree. But horizontal component, that is, we have to draw this line. Now think, this angle is 60 degree and this angle is also 60 degree. So we are going to find the horizontal component of flux. So phi h is equal to phi 1 minus phi 2 cos 60 degree. So in the here it will be cos 60 degree minus phi 3, again phi 3 cos 60 degree. So this is equal to phi 1 minus phi 2 plus phi 3 cos 60 degree. So what is the value of cos 60 degree? This is half. So phi 1 minus phi 2 plus phi 3 into half. So what is phi 1? We know phi 1 is equal to phi m sine omega t. Phi 2 is equal to phi m sine omega t minus 120 degree, and phi 3 is equal to phi m sine omega t plus 120 degree. So putting all these values, what I am getting, phi h is equal to phi m sine omega t minus half into phi m sine omega t minus 120 degree plus phi m sine omega t plus 120 degree. After resolving what we are getting, phi m sine omega t minus half. So there will be phi m by, I can take common phi m by 2 sine omega t minus 120 degrees. So that is equal to sine omega t cos 120 degree minus cos omega t sine 120 degree. So sine omega t cos 120 degree minus cos omega t sine 120 degree. Now for this again I have to write plus, here the sine omega t plus 120 degree. So this is there will be sin A cos B plus cos A sin B. So sine omega t cos 120 degree plus cos omega t sine 120 degree. Now in this expression what we are getting, this is minus cos omega t sine 120 degree. So this is plus cos omega t sine 120. So this is cancelling each other. So what we are getting, 2 sine omega t cos 120 degree. So this is equal to phi m sine omega t minus phi m by 2 into 2 sine omega t cos 120 degree. So here 2 cancel. So this is equal to phi m sine omega t minus phi m sine omega t into cos 120 degree. So cos 120 degree is equal to again minus half. So from that what we can write, phi h horizontal component of flux is equal to sine phi m sine omega t plus phi m sine omega t by 2. So this is equal to phi m by 2 phi m sine omega t. So this one is the expression of horizontal component of the flux. So resultant horizontal component flux is given by phi h is equal to 3 by 2 phi m sine omega t. Now the resultant vertical component of flux is given by phi v is equal to now we are finding the vertical component. So for phi 1 there is no vertical component, so it is 0. For phi 2 we can see this angle is how much? This angle is 30 degree. This angle is 30 degree. So for vertical component we can see phi 2 cos 30 degree, and this is for phi 1 cos 30 degree. So phi b is equal to 0 minus phi 2 cos 30 degree, phi 3 cos 30 degree. So this is equal to, we can take common cos 30 degree. So it is phi 2 is equal to phi m minus phi m sin omega t minus 120 degree. Here it is phi m sin omega t plus 120 degree. So cos 30 is equal to root 3 by 2. So inside we can take common phi m. So minus of sin omega t cos of 120 degree minus cos omega t sin 120 degree. And for this is sin omega t cos 120 degree plus cos omega t sin 120 degree. Now this one is minus, this is plus, so we can cancel each other, and this minus, this is plus. So 2 cos omega t sin 120 degree. So root 3 by 2 phi m into 2 cos omega t sin 120 degree. So this to cancel. So root 3 phi m cos omega t and sin 120 degree is equal to root 3 by 2. So this is equal to 3 by 2 cos omega 3 by 2 phi m cos omega t. So this is equation 2. The vertical component is equal to phi b is equal to 3 by 2 phi m cos omega t. Now the resultant flux. Resultant flux phi r is equal to under root phi h square plus phi v square. So this is equal to 3 by 2 phi m sin square sin omega t square plus 3 by 2 phi m cos omega t square. So From here we can get this is equal to 3 by 2 phi m and under root sine square omega t plus cos square omega t. So this is equal to 1. So this is equal to 3 by 2 phi m. So this is constant. But so ultimately resultant magnetic field or resultant magnetic flux has constant magnitude. Tan theta is equal to phi v by phi h. This is equal to 3 by 2 phi m cos omega t divided by 3 by 2 phi m sin omega t. So this is equal to cot omega t. So I can write it as 10 pi by 2 minus omega t. So tan theta is equal to 10 pi by 2 minus omega t. So therefore theta is equal to pi by 2 minus omega t. So this is my phi h component and this is my phi v component, that is the vertical component and horizontal component, and resultant is phi r. So what we have seen, phi r is equal to 3 by 2 phi m. So as theta is equal to pi by 2 minus omega t, so what we can draw, so let's draw first B, C, D. And phi r is making angle. This angle is theta. And we have seen that theta is equal to pi by 2 minus omega t. And this omega t is maybe 0. If omega t is equal to 0, then theta is equal to pi by 2. That means here it is. So and phi r is equal to 3 by 2 phi m. So this is independent of time and it is a constant. Flux of magnitude is equal to T2 times of the maximum flux per phase. In this equation, if I put theta is equal to 90 degree minus omega t, so at omega t is equal to 0, so theta is equal to 90 degree. So here it is phi a is equal to 3 by 2 phi m. So this is, we take this is as small 1, condition number 1. So at omega t is equal to at omega t is equal to 90 degree, that times theta is equal to 90 minus 90, that is 0 degree. So now we can see this is the position B, where theta is equal to 0 degree. So this is phi B is equal to 3 by 2 phi M. Now at omega t is equal to 180 degree. Now at omega t is equal to 180 degree, theta is equal to minus 90 degree. So theta is equal to 90 minus 180 degree. This is equal to minus 90 degree. So now we get the condition at C point corresponding to the position C. So phi C, again this is equal to 3 by 2 phi M. At omega t is equal to 270 degree. So theta is equal to 90 minus 270 degree. So this is equal to 180 degree minus. So now we get the condition D. So phi D is equal to 3 by 2 phi M. So what we can see, resultant flux so it is seen that resultant flux rotates in space in the clockwise directions with angular velocity omega radian per second. So this way what we can see, the resultant flux rotate in clockwise directions. So three-phase balanced supply produce the resultant flux of constant magnitude in the air gap of the motor, and magnitude of flux at every instant is 3 by 2 phi M. And omega is the angular velocity. omega is equal to twice pi f, and the synchronous speed ns is equal to 120 f by p. So f is equal to p into ns divided by 120. So this way we can see that the resultant flux is rotating in the air gap, and it is rotates in the clockwise directions with the angular velocity omega radians per second. Thank you very much for watching.